All right. So we are actually doing this machine learning after a bit of a time. So what I'm going to do is from where we stopped, we are going to start doing some interesting coding exercises, and whereby we are learning about different techniques in machine learning. So we basically talked about the basics of machine learning, and now we have to start with linear regression, right? So which is like one of the first types of machine learning that we can implement, right? So for this, I'll be using a PyCharm. So you guys can, of course, use any other tool that you are interested in, right? So you can use Jupyter Notebook. So we talked about this. So it's basically you can use whatever necessary interesting tool that you're planning to use. So I'm using PyCharm, right? So basically how to work it out, and you can use the notebook as well. So what I'm going to do is to teach you linear regression. I'm going to do a basic this house price prediction, right? So house price prediction is some common type of exercise that we do in linear regression. So to understand linear regression, this would be a good example. So basically, we are looking at say house prices in Sri Lanka, in Colombo. So basically, you need to have set of features. So here we use very basic supervised learning. So we'll assume that we have area of a house, right? And then of course we'll have the price of the house. So we'll keep it very simple. This is a starting exercise. Thereafter we can go for advanced exercises, right? So we'll assume this is from square feet. So we have a house of 2600 uh, square feet, and the price would be like 5.5 million, right? And if it is 3000 square feet, it is say 5.65 million. And we look at another one, 4000, which is a bit of a larger house, uh, where it's 7.25 million. Right? So assume from LKR. Right. So basically, you will find a list like this. So once you have a list like this, you'll be able to, using your basic knowledge, right? So being a plot, right? So basically a scatter plot. So this side you will have the prices, and this side you'll have the area. So you will have your areas listed here and your prices listed here. Then you can basically plot these values, right? Value pairs. And then what you should do, you should basically draw a line covering this. So of course there are some errors here and here and here, but you can draw this line which is in the form of y equals mx plus c, right? Plus c, right? So in this format, if you can draw this, you'll be able to predict some house price that you are not really sure of. So you can predict a house price for an unknown, for an area which is price is unknown. So that can be predicted using of setting up this basic line or this equation, right? So that's what you do in linear regression as well. So basically, all right. So then we need to understand. So take a new whiteboard. Okay, so we have to now understand. So we are using the same equation, y equals mx plus c. Right? So it's y equals mx plus c. So basically, y is the home price. So it's the home price. Okay, home price, and so that's what we have to predict, right? So m and x is the area. Alright. So we need to find out this m and b. So that's the challenge for us, right? So this is how the equation goes, right? So this is the gradient on slope, right? So from your maths, high school maths, you understand it, and also this is the intercept. Okay. So that's the very basic maths that you want to know, and basically what you find is if you draw a line like this, okay, so this is b, okay, this is b intercept, y intercept, and also this is n, right? So n is the slope, okay, n is the slope. So that's what we are looking at. So if you want to basically give kind of equation for this, mathematical equation for this, you can say this is from I equals 1 to n delta I square. So that's basically the function that we want to implement, and this should be the minimize. So this has to be the minimize of it, right? So that's the logic behind. Okay. So now we'll be able to work out the coding of it. So we'll not go too much detail into other things right now, but rather we'll go and look at the coding, right? Okay. Alright, so I'm going to use PyCharm. So I will create so one thing that you remember is when you use PyCharm, unlike Jupyter, so you have to install your software in this, especially the packages, right? So you have to basically go to the project. So I have not given a name for it, and you can find the interpreter, project interpreter, and I have selected Python 3.7, and here I find all the necessary libraries. Matplotlib is installed, pandas is installed, pip, numpy, scipy, scikit-learn. I have not installed TensorFlow yet, but if needed, I will install it. For this shallow learning exercise, I don't think it's necessary. But when you go to deep learning exercises, we'll need the TensorFlow package. So there we will install it. And also sklearn, scikit-learn. We have installed. No? Alright, so make sure that you install it, or you can. So this is in the environment. If you want, you can have it in a default environment, and once you create in the project from here, you can basically get it downloaded from the default environment. So both. So I think we have discussed that. So you can do that in that way. So I will create a Python file. So this is basically linear regression. Okay, so let's hope the font is clear. Otherwise, I can go quickly to the preferences and editor font. So okay, so we'll go as 18. Alright, so now we'll start writing our code. Okay, so first we need to import our libraries. So that's what we have to do. So I will import pandas first. So pandas is for data handling. So normally we it as pd, and we need numpy as np. So I didn't get an error, so everything is installed, so no issue. And then getting scikit-learn, import the new so those are the things which I need. Other than that, I'm going to do some scatter plots and all that. So for that, I need the matplotlib, the PyCharm, right? So I'll make it as PLT. So the quick references are there. And then I have created a small CSV file. So as you can see, you have the area and the price. So we have those values here. So I have already given those values into the CSV, and it's already there in my folder. Right. So I'm going to load this one, and so don't worry. You can create a CSV, small CSV, or I will upload into my GitHub, which you can access. I'll put the link after the session, so you guys can download it. Right? Or else you can create a one, so there's no worries. Right? So I'm going to use pandas and I'm going to read it as CSV. So the CSV file is home price is CSV. So that's all fine. So once you read it, so I'll compile this now. Okay. Okay, so yes, right. So if I want to print this, or if I want to, just want to get some output, I think I have to put it to data frame, and so I'll just see how it looks like as a data set. Okay. So alright, so now that part is done. So I think I can now, so I have the data set loaded. So now what I'm going to do is I'm going to basically do a scatter plot. So I think you can use matplotlib for that. And I have to label the x. So what is x? So basically x is the area. I'll start it. Then PLT y label. So here what we have the home price. Okay, home price from here. So that's done, and then I can do a scatter plot. Alright, scatter plot, and I need data. I have to give the data, so I have a data frame. So I have to use the area as the x. Alright. It's out here. So that's x, and then price would be the so the y, that's y, and then you can give some formatting. You can do some formatting. You can set the color to red, okay. Color to red, and marker the marker also. Marker the marker plus marker. So that will be the plotted values, right? Or aspect. Okay. Alright, it looks fine. Now I need to, if this is a Jupyter notebook, basically you guys can do a matplot inline, and you can see the output, or otherwise you can do a PLT show. You can do it in this way. Alright, so I'll run this code. Alright, so you can see the values plotted. So you haven't done any regression yet, so you don't have the line, but you can see the home price from NKR and the area of the house here. So you can, so So basically, you can see there is one here, as you can see all these things here. Okay, so I think that's it's all glass exactly, right? So so let's go. Right? So we have the here. So if you don't want this to be seen every time, just comment it. Thereafter, you won't be able to. It won't come automatically. If you need only, you can uncomment it. All right. So that part is clear. So now we go one by one. So now what you do? Now we try to do some modifications to the data frame. Right? So we'll drop the price and see like how it works out. Okay, drop the price. Okay, and that's is what we call it. So that's where we are going to. Okay, and this will be a space here. So this will be a new data frame. So I will put new here. So that will be the thing. Then I can check the new data frame. Alright, so that's that. Okay, so now if you click on the Python console, you can see the data registration. It should show the data frame here. We have it at so it should have the data frame right now. Okay, so now what we should do? So now we should be able to. Now we have a new data frame, so we can extract the price from it. So from the old data frame, we take the price. Okay, and then we can create this variable called price. So we should be having all the price values. Right? This. All right. So I had this issue because I was not using a print statement, so I printed it. So now if I check, I can see the data set clearly. Okay, so I can see the data set, only the area, because I have dropped the price on the column. So in the new data set, you can see only the area is present. But if I print this one, okay, I'll be able to see both columns. So this sort of techniques you have to use when you're dealing with machine learning code. So you can see the area and the price both present here. And if I will comment these lines. Okay, and then I will uncomment this one. Alright. Okay, and then I will run this. Okay, so I can see relevant information, the price information. So I need the price information taken from, and then you can see even the data type of price. Okay, that's done. So that particular activity is done. Okay, then what I'm going to do, I'm going to now create the linear regression model. Okay, so I'll make a comment here. Next, create the linear regression object. Okay, so to do that, I'm going to use linear model. Right. So I'm going to use the linear model. Okay. This is from scikit-learn, and inside that we have all these things. We will learn some of these things later, like this. So that's painting here. So I'm going to use logistic regression here. So I'm going to use linear regression, right? So it's function. So then the return value I put here this regression object. So then what I'm going to do, the regression object, there are two functions, coefficient. I can get this intercept coefficients, those things separately. I can normalize. Right? But here, what I want to do is the initial activity, which is the fit function. So to fit it, what I'm going to do, I'll be sending only the new df because I need the areas. Right? So I'm going to send the area information. So and of course I will send the price. So I will set it to two different values. So that's what I'm doing here. Rather than sending the single data set, I will send x and y. So that's what I'm doing it this way. So there are so many methods you can do this. So this seems to be the easier model. So now because we have it built on this now. Fine. So inputs are on this there also. So things looks fine. Alright. So everything looks fine. So now regression model has been applied. So now I can predict something. Now I should be able to predict something. So because now regression model is being trained, so I'm going to predict. So of course to predict, I need to provide a area value, right? So that's what I do. So I'm going to give an area. So if you look at, so here we have 3,200, 61,300, 68,000. Sorry, it's not 600,000. So you get values like that. So I'm going to get those somewhere in between, somewhere in between those two values. You should also get some value in between. Basically, maybe you can guess it. So I'm going to give something like 3,250, so 350. Alright. Let's say 300. Alright, so now what I'm going to do, I'm going to run this. Oops, so because of this array shape, I might need another bracket set. Let me check that. Yeah, so I found. So I print this. Let's see. See, there's all cool, right? So see, the value is something around the line of 628,000, and there are some floating values also. That's all fine, right? So this is what we expected. Right now, we'll try to get this equation. So we don't know the equation yet, but we can find it out. So then, of course, we can build this equation, right? Get this equation, and we can write y equals mx plus c. So now we need the m and the c. So then we can bring up the model and then we can apply it and we can understand what's happening. Right? So to know that, I'll do another print. So I'm going to print the coefficient first, right? So yeah, just print it. So this time what I need is the coefficient. Coefficient, right? So I need the coefficient, and also I need the intercept, which is m and c. So m and cs. So let's see the output. With those two values. All right. So we are getting the first value, which is 135. So that's C. Okay. So this is C. And so that is 135. 787. Just write only that. And then the M is 8,616. So this one is 180,616, right? And then 48. Okay, that's good. So now we know the equation, right? So we know equation. Okay. So now we can write y equals mx plus c, right? So now shall we write it down? So we'll do the print. We'll see whether it's working. Print. Not sure we can do the equation like this, or like 2300. That is mx. So that's x, and now we will multiply it by m. So this is our m. Alright, so I put it down, right? So actually this double around. So this is this one, and this is this one. Okay. So sorry about it. Alright. So this is the intercept and this is the coefficient. Okay. So we have it here. So this is the intercept. This is the coefficient. How this look? So we have to get this value and multiply. Okay. Plus, should be plus, right? Yeah. And plus this one. So now, so this is we are testing our prediction model, right? So okay. So we don't need these values anymore. These things. Hold on. Yeah. Okay. So now we'll see whether the equation runs. Alright, everything is cool. So see, I do the prediction. So this is the prediction one. So this is predicting through the model. This is we are building it manually and we are predicting it. So hope you can understand that. Yeah, so it's the same value, right? Same value. Okay, it's really cool. So nothing. We can do this manually because we have the values. For a complicated situation, we need this model. Right. Now what we're going to do, now we know the equation, we're done with that, right? So now we have to, oops, sorry. And then we'll do another prediction, this time. Send 5,000 this, which is a value which is not listed here. Yeah, so now we should, so it's only goes up to 4,000. So we're getting this, so we want to print this value, and we can get an idea about what is the house price. And comment this as well. Alright, so it's 85,000, 8 million something, right? 0.8 million. Right. So yeah, so we get that value. Okay, now what we're going to do, now we are going to do a bulk prediction. For that, I'm going to use another Excel file. Let me show you that Excel file. Okay, so I will open this. So that's this Excel file. So you can see the only areas are listed, right? So areas are listed. So what my plan is to input these values for the model and to get the predicted values. So this is named as areas and this is CSV file. So what I'm going to do is I'm going to drag and drop this areas file and it will be in my project directory. So I can use it. And that's the purpose. So what I'm going to do now, okay, so I'm going to read the file, so pandas library, read CSV, so I have to use areas.csv, and this will be a new data set, area, so we name it as area PF, okay, and I'm going to get the first few values of the data set. First three values is the most function for area. Oops, area. This should be it. Fine, so I'm going to print this. So you can see you are right. Get the three values. Okay, the first three values. Now, what I'm going to do, I'm going to do the prediction for all the values, right? So, reg.predict. Okay, and so I'm going to pass the data set, and decided value I will put it to a variable. I will put it as predicted value. Okay, and then I can print the predicted value. So all fine. Spaces here. Okay, so we'll wait for the output. Alright, so we get all the output. It's all fine. So this is what we expected. So now, so this is not very user friendly. So what I'm going to do now, I'm going to put this into a nice sort of a table. So what I'm going to do, so I have the area df, and I'm going to add the new predicted value as say predicted price, and then I'm going to add the p to this one. Okay, so should be predicted value. Okay, and then if I print the area df, I don't need this anymore. I don't need this anymore. Okay, I'm going to get the printed value. So now I should get the so everything's fine. So I get the area and also the predicted prices. Okay, so all that is fine. So now a bit of a fun stuff. So now what I'll do, so I have everything in area df, the data set. So I'm going to, there's a function called to CSV. So I can create a new predicted check here in my project directory. So if I want, I can open terminal. Yeah, so you can see the file is there, predicted files. Yes, so I can cut it. Okay, the files are there. No worries, right? Okay, so that's pretty cool. So this is the kind of a very basic machine learning pipeline. So what we did was linear regression, right? So then we can try to do a multiple linear regression. So this is like single variable. So now what you can do, so I will give you a data set. So it's like a homework or sort of activity. So I will give you this Canada's per capita income for 2020. So you can get that file. I believe I have that file with me. Let me show you the file. So this is the file. So we have all this info, year and per capita income. So what you have to do is you can get the file using the wheel regression model, predict the per capita income for Canadian citizens for year 2020. Okay, so this is what you guys have to do. So I'm going to add all these files, but I have developed and all other files to my GitHub. So let me go to my GitHub account and I'll create the report. Let me say ML. So I will put this in linear. I can have a dash in between. That's done. Okay. So I'm creating the report. So I'll first put the exercise file. Okay, so that file is there. And then I will put the other files which you can use. Yes. Okay, so what I'll do is I will add those files to the list. and so the GitHub. So the moment the file is, I got this file. The rest of it I'll also add here. So please get these files from here and go my GitHub and please get the files from here, right? Yeah, so that's the first part. So please wait for the second one. So probably the second one, what I'm going to do would be linear regression with multivariate variables. Then we go for the logistic regression, and again logistic regression with multi-class, and then decision tree, SVM. So likewise, I will go those files. And please make sure to carry on with the project work. So I will explain all these things again, and all the whiteboards and everything I'll share. So make sure to get this video and follow through. Okay. Right. For the moment, okay, so make sure that you do these activities, try this code,